Right, 10 a.m. Let's kick this off. So, hello everyone. Welcome to the webinar. Before we get going, just some brief housekeeping from us. If you've got any questions, use the chat box or the Q&A. We'll do our best to answer them, and any questions we don't get to, we'll follow up afterwards. The session is being recorded and will be shared after the webinar. Any tech issues, let us know in chat. Joel is in the chat and we'll be able to help out. And obviously your audio is muted, your cameras are off, so they'll stay that way for the call. So yeah, welcome to Elite Performance, unlocking speed, stability, and scale with AI, DevSecOps, and CI/CD. It's quite a pivotal moment in the software engineering sphere. We've got a lot of people coming to talk to us about how do we unlock AI, various experiences in that. And Sam, Fane, and I sat down a little while ago to write the ebook Elite Performance, which has led up to this webinar. And Joel asked us an interesting question. What happens when you introduce AI into the mix? What does it do? Obviously, we know the software engineering landscape, all of us, it's undergoing a seismic shift. And the rapid adoption of these Gen AI tools is driving that. Organizations globally are racing to introduce these LLMs like GitHub Copilot, ChatGPT, Claude Code into the development workflows because they offer an awful lot. A dramatic increase in coding velocity, democratizing software creation even further than it was already, and starting to eliminate this blank page problem when you're staring at a screen going, how the hell do I solve this problem? But while driving this sort of massive technical leap, it's also exposed a critical issue in the operational backbone of many enterprises. While AI is accelerating code generation at an unprecedented level, it's simultaneously stressing the delivery lifecycle like nothing we've ever seen before, where the increased velocity from AI risks becoming wasted effort that never converts into actual delivered business value. And so that's what we're here today to discuss. At this point, I'd like to introduce myself and my co-authors who are with us today. I'm Ed, a Principal Client Solutions Engineer here at Codurance and your host for today. My background spans everything from running networks of Counter-Strike servers out of my bedroom to architecting large-scale systems for the travel, pharma, and fintech sectors. My focus is really on software architecture as a business tool. So helping organizations understand that things like tech debt, it's not just messy code, it's a business risk that slows down time to market. And today I'll be discussing how we actually achieve the goals of elite performance that we set out in our ebook in the age of AI. Joining me on the call is Sam Griffiths, also a Principal Client Solutions Engineer and a Platform Engineering Specialist. Sam has a history of building high-performing teams and robust cloud systems for enterprises. And he takes the view, I think it's safe to say, that the delivery pipeline is a product in itself, one that serves your developers. And that's a vital perspective today, because if we use AI to push more code through a narrow pipeline, then things start to break. Outside of work, Sam, at least according to your bio on our website, you are currently training for a half marathon. So I'm going to say you should know things about endurance and pacing, which applies pretty okay to software delivery. Don't know if you've succeeded there yet.
I have actually. I need to get It's just a good reminder. I need to start running again.
And rounding out our panel today is Fane Fonseka, who's a lead software craftsperson or team lead at Codurance. Fane started out with statistical modeling and data analysis before moving into engineering. So he's got quite a unique view on the data side of our industry as well. Deep experience as a full stack engineer, mostly in .NET and React. But as Fane, it's safe to say your real passion is this software craftsmanship, agile delivery side. Fane's providing a bit more of a boots on the ground perspective today. He'll be arguing that things like TDD, hopefully, aren't optional extras, but are actually the only real way to integrate AI safely without completely destroying your code base. So that's about us. I'd like to start the discussion today talking about why these sort of hidden foundations that we set out in the ebook that set teams up for this elite performance are now more critical than ever in the age of AI. And the first topic I'd like to talk about is AI coding assistants directly. They're fantastic. We use them internally and externally, and we have seen our velocities increase a lot. We've seen clients have their velocities increase a lot. But there is a hard truth there as well, that if you double coding speed without fixing that pipeline, you don't really get faster feature delivery. You might get faster features, but they don't go anywhere. You end up with a bottleneck in your pipeline around CI/CD and this sort of stuff. And it's a bottleneck that's twice as big because you've rammed twice as more code through it. So Sam, over to you. In your experience, why do these what might be 10 boring foundations like CI/CD matter more now than they did 5 years ago?
You just rage baiting me saying the boring foundation. But I think if we take a look at the last 5 years, right? So maybe 4 or 5 years, LLMs came out, GPTs were a novelty. Everyone was kind of like, oh, this is cool. I wonder what we can use this for. And then over the years, and I think in especially 2025, that's where we've seen real adoption from pretty much everyone we work with, even internally across the company. Everyone's using coding agents and assistive AI. So what that means is we're seeing an explosion in just the amount of code that's being written. And obviously with that, you get inherent potential complexity. There's ways to control the AI that I guess we might go into a little bit later, but fundamentally you're getting more and more stuff written. So there's more and more stuff that needs testing. There's more and more stuff that you're going to have to get through your CI/CD pipeline. And with that, you kind of get the potential for more stuff to go wrong, I guess. So the CI/CD pipeline effectively becomes your safety net for getting stuff into production. If you don't have that and you kind of take a nice cowboy approach and just deploy straight out without sufficient testing and security and things like that, then you're greatly increasing the risk of things going down in production, essentially. So where CI/CD has kind of had its moment, didn't it, in the 2010s, I think it's becoming even more important now that we have with the onset of these coding agents.
That's a theme we keep seeing, that the ongoing acceleration of development. It's fantastic, but you have to have those solid foundations in place in order to be able to back up that increased velocity.
You're not going to be able to stop it, right? Because you need to enable your developers are going to get features out more quickly. That's just going to happen. So you will need to put some certain controls in place to make sure that's still done safely and effectively. But sorry, Fane.
Yeah, and I think also, you're not going to stop developers using AI. This is a tool that, they want to use and they kind of reach for. So, no matter your view on it, it will be getting into your code base, in different various forms, really. So it's important to make sure that you put the guardrails in there to make sure that it's kind of being under control, I guess, controlling the beast. Yeah.
And it's a direct business challenge as well, because these tools do cost quite a bit of money. Like when you've got a reasonably sized development team, you could be spending thousands of pounds a month on these tools to try and make them move faster. A particular client, Sam, I think you know the one I was talking about, or I am talking about. They had just bought Claude Code for their entire development team. It's about 50 engineers, I think. And that creates an enormous pressure to deliver faster for that technical department. And they were really struggling because they didn't have the supporting CI/CD DevSecOps foundations in place. And so that bill that's running at hundreds of thousands of pounds a year potentially is just not delivering value on that. And the business is was getting frustrated because the value proposition for that is actually quite bad. They weren't seeing that corresponding increase in value delivery. Fane, we were talking yesterday about a client who had imposed even further restrictions around that sort of getting code into the pipeline and then out I think you said something about a client developer wanting to review every PR. Do you want to talk a bit about that?
Yeah, sure. Yeah, this was yeah, quite a pain really. So uh, so we were actually developing quite quickly, and at this point in time, I think our devs were using a bit of ChatGPT to kind of increase our speed. So we'd be getting our features dev done near the end of the sprint, but because we had one client developer who wanted to review everything, it became a massive bottleneck at the very end of the sprint to be able to get things done. So although we had things dev done, there was that kind of slowdown near the end in terms of code review, and then also getting feedback back for the devs to make their changes. So um, although it's a little bit on at the end of every sprint, it kind of delays you in terms of your final delivery, I would say. Um, so that's more of a kind of like organizational process based problem. Ideally, we'd be able to have developers pairing and doing that kind of code quality check as they're developing, and so that they can kind of merge the changes in as they go along, I'd say. So it's important to have a look at the people aspect as well as the technology aspect in terms of your delivery pipeline.
And that was a key theme of the ebook. We set out the sort of three interconnected practices that underpin what we would consider high performance software delivery underpin high performance software delivery departments. Those were continuous integration, or each code merge automatically triggering a build and a run of a test suite. Continuous delivery, where each code change that successfully passes all those tests is automatically packaged into a production-ready release artifact. Typically, actually going to production is a business decision and a business risk thing, but ideally the software should be in a state where it can always be released to production at any time. And continuous deployment, which is that every validated and tested change automatically is deployed directly to production without any human intervention. And that maximizes the speed of delivery. You can see how this would start to feed in as you're generating more code. It can go out faster and deliver faster value. And it allows things like new features and bug fixes to reach customers within minutes of being completed. But Fane touched on an interesting topic there, which is organizational trust. The distinction between continuous delivery and continuous deployment is that gate before a production release. And it only exists, it's a safety net, because the organization as a whole does not trust its automated quality and security processes throughout the development lifecycle enough to allow those releases without a final manual check. And I think the requirement to feed all pull requests through a single developer for review is also emblematic of potentially weak organizational trust in that technical department. And it is something we see all the time, places struggling to trust their engineers to produce reliable code. So yeah, we've kind of touched on a bit of a velocity paradox there, which is if you double the speed of coding without fixing the delivery pipeline, you kind of create that twice as large a bottleneck. Now, we try to measure the delivery of value to customers using the DORA metrics framework. It's been around for years. They publish an annual report, which is worth a read. And measuring those metrics can really help highlight these issues on unmaintainable or legacy code. And delivery pipeline bottlenecks. Now, it kind of segues us quite nicely into the next topic, which is this trap of speed versus stability. Why this faster code generation driven by AI often leads to lower stability, higher waste if your delivery practices aren't strong enough. Fane, if we thought about the speed of delivery, and with AI we're moving faster, what happens to the teams and the developers in that environment where there's this pressure to keep moving faster?
Well, I think it's the same as the pre-AI days where you've got a delivery coming through and there's a lot of pressure coming from your product owner or the business to try and deliver, and so the devs try and bash out as much code as possible, and they're trying to optimize for that speed of delivery and rather than the actual code quality. And so you've got that with AI, but kind of 10 times the amount of speed of delivery here. And so you're going to have the same proportion of failures that are coming into prod. And really, as it all has been, it's quite a short-term view. It's a bit of a false economy because you might get your features out for the end of your sprint or whatever, but the next sprint you might have some production issues, and then you've got part of your team having to work on that rather than actually delivering value. So it's not really a good long-term kind of plan for that. It's always better to take a bit more time to get your code quality standards in place first, so you don't have to have the headache of dealing with production issues, really. Yeah.
I think the Dora AI report last year was really interesting. It was talking about how there's no doubt that AI tooling boosts productivity for developers and increases their satisfaction because they're like, oh, look at all these things I can do. But what it doesn't do is have a direct impact on those Dora metrics. So it doesn't necessarily allow you to get code out faster to production. It doesn't necessarily reduce the number of failures in production. All it does is mean you've got more content to manage going through that pipeline.
And spiking that change failure rate specifically causes a ton of issues, doesn't it? Because I've been in environments where you spend all your time fixing bugs you didn't write, and that's infuriating as a developer, like constantly having to uncover why something broke, and you feel like you're always operating on shifting sands because you don't have a stable thing to build on. I mean, in that particular environment, the development speed was literally zero because we were constantly fighting fires. I can't imagine what that's going to do to a dev team in the age of AI. Like, Fane, what does it do?
Well, yeah, I was just about to say, if you've not got enough guardrails in place, I guess, with your AI coding tools, you're going to start making very funky code, I guess you could say. And as a developer, I've gone in and you've got that head scratching moment of like, why is this piece the way it is? So you're spending a lot more time trying to understand the code. And then, likewise for the AI will then just building on top of that code, and, making it even more tangled. So I think one thing I found is that if you can start with a good base, if you're doing some AI generated code, then the AI using the code that's already there will be able to build on top of those foundations. So it's all the same kind of principles as the pre-AI days, I would say. Yeah.
I think it comes into that. A lot of the time with CI/CD, you talk about the shift left approach, don't you? And I think going as left as possible when you're using AI coding agents to provide it those clear instructions, those clear plans. This is what I want my output to look like. Is really, really important so that you can be at least a little bit more confident that what you're delivering is aligned to the engineering principles that you want to deliver your code with. And that's something that we've done. We've got some internal projects at Codurance looking at exactly that sort of thing, which I think David, who's done one of these webinars before, has been working on, looking at how do we embed software craftsmanship and software craftsmanship principles and stream programming and all that stuff into AI coding agents to allow us to be at least a little bit more confident that what we get out the other end is aligned with what we want to build. And I think we've seen over the last year that they're getting better and better every day, aren't they? And if we don't be very, very clear about this adoption and really leaning into it, then I think organizations will ultimately fall behind because that the productivity increase is just so much higher.
I think that's something that's worth digging into a bit further because Codurance recently ran several experiments. We published articles about these AI code retreats that we've hosted. What we did there was we wanted to just see how developers without organizational overhead can work with these tools. And we came up with some pretty shocking statistics, actually. One that springs to mind is the 4x stat where AI can send code complexity through the roof. Fane, do you want to talk a bit more about
that? I think that basically we had an experiment running where we had one half of the group using AI tools, and then one other half of the group not using AI tools. And the group that were using the AI tools, they found that they were producing 4 times more code, which I mean maybe on paper might be good, but yes, like you said, the complexity of the code was 4 times larger. So you'd have more branching logic, and you'd basically put yourself into more of a position where you'd have more kind of intertwined spaghetti code, really. So it's not necessarily the case that all code is good code, I guess. It's important that you've got distinct quality code coming out of it.
And what can we do there to ensure, if we thought about this from an organizational perspective, what can we do to ensure that the code that is being generated is, reliable and with low complexity?
That's quite a good question, actually. So one thing I've been doing with a tax client that I'm working on at the moment is I've put together some AI coding, kind of like a framework, really. Basically, kind of explore, plan, execute, and then review. So making sure that you explore the kind of business problem that you have, finding out what kind of solutions there are, and also giving your ideas. Then once you've picked your kind of implementation, going through with the plan, making sure that it doesn't get stuck in a death loop, and then also that in the execution, and then finally making sure you do a review. And the review is actually a really critical part of this, that you're actually going through and trying to understand what, I guess, Claude Code or whatever tool has made, making sure there's anything that isn't too strange, I guess. But you can also use Claude Code to be able to do the review yourself. So that's the kind of like framework I've put together for my teams. In addition to that, I think a good foundation is setting up a good agent MD or Claude MD. So this is kind of a file that you're giving the agent a framework and a reference to kind of guide it, basically. And in this kind of document, we have actually a few shared kind of guides of, craftsmanship.md, where it has the kind of principles that we want to be having the agents be following, such as, solid programming, dry, separation of concerns, and also architectural concerns too. So I think by actually, writing down all these principles and giving it to the agent, you're then kind of pointing it at the right content that it's been trained on, so that you're more likely to be able to create good quality code. However, I think the most important thing is that it shouldn't replace your thinking. You should always be in control. You should always be knowing why it's gone down a direction. And at the end of the day, and this is what I say to all my developers, is that you're responsible for all code you've written, no matter how you've got it, Stack Overflow or, agentic AI, you are responsible, and you should be able to explain and defend all your code. So there's a bit of accountability there, I think. So, yeah.
And how does, sort of a bit of a wider question, Codurance is very much a software craftsmanship oriented company. We are strong proponents of things like TDD. In the age of AI, and this is a terrible question, in the age of AI, is TDD dead? Or, is there still a way to use it to help us kind of bring clean code and clean crafted code back?
I think there is a habit, for at least for agentic tools, even if you put into your Claude MD or Agents MD, make sure you write the test first. It will often write the implementation first. I think there are some tools out there to kind of slap it on the wrist and make sure that it's actually writing the test first. But it will write the test, at least, afterwards. So yeah, I think it is still very important that any code that you write is tested, because the more code you write without testing, the further far away you'll know from if your system is actually working as it's intended. So it's your safety net. And I think as you were talking about like safety nets before, I think these are all safety nets that allow you to feel kind of certain in what you've delivered. Because without those safety nets, you start to wonder what might be broken. You might be doing some over checking on manual testing. And again, this slows you down. You want to be free to be able to just keep coding. And the way that enables you is by having a nice set of tests that prove that what you've written actually works. Yeah.
I think quite topically, there was a high severity bug with Claude that I think came out maybe this week. It's very, very fresh, where it will actually ignore Claude ignore and Claude MD instructions and start including the contents of secrets files and local end files, this sort of stuff in the prompt windows. Obviously, then you've got disclosure problems, and it can actually do things like embed secrets within the code it's generating. I think it really highlights that these tools, while they're capable of delivering immense value, they're still capable of ignoring instructions and just doing something completely random. Obviously, that creates an enormous level of organizational risk and the need to validate what's going on, need to check code before it goes out. And a robust test suite can do a lot of that. But I think if you don't have some like other tooling in place to catch problems, then you've got issues like potential secrets leakage. Sam, what could an organization do to kind of mitigate that sort of risk? Is there something they can do in the pipeline, maybe?
Security, right? The same principles apply. So like everyone gets really excited about AI, but the same principles apply to what you were doing before, about 5-6 years ago. You need to be confident, like Fane was just saying, you need to be confident in the code that's going out. You need to have it well tested, secure. All of those types of things still exist. It needs to be cost efficient, potentially, like in the platform engineering world. You need to have automation. So yeah, I guess what you're leaning into there, Ed, is around sort of what we term DevSecOps practices, I guess, and embedding security as far left in the pipeline as possible. There's an interesting discussion we were having yesterday, actually, which is around we can still use AI to help with this, right? What we're not saying is that there's CI/CD over here and there's AI over here and they need to clash. I think they can complement each other. And you can use AI tooling to start an agent on a PR, for example. Tools like CodeRabbit and things like that can do security scans on the code that you've generated as they're going into the pipeline. So open a pull request and AI agents can scan that and you can set your security rules around that. So that can be useful. But yeah, the same old principles apply, really. So tools like static code analysis. If you're in containerized environments, you still need to be scanning your containers, all that sort of stuff. We can, again, coming back to what Fane was saying about setting up your approach for using tools like Claude, you can also embed security constraints into the instructions as well. So I think we just need to be aware that we shouldn't drop all those practices just because we can now generate code faster. They still apply and they're still just as important. And we've done that. We use that internally for some of our tooling as well, just to make sure that I think what I found actually using AI tools, I think they've got so much better in the last year or so that they often build or suggest improvements to code, which is more secure than what I would have done previously. So you can leverage them for that, because I mean AI tools great for ideation, right? So it often suggests things that you might not be able to hold in your head, because obviously there's so many different security things going on. So I found them useful for that, and I think I'm not trying to divert the conversation to platform engineering too much, but I think they're getting a lot better for tools like building pipeline files, building Terraform code bases and things like that. I think when I first started using them, they would just be hallucinating all over the place. And it was just a complete nightmare, to be honest, because it just wasn't trained on enough data. I think what we've seen over the last year or so is it's becoming better, but and by better I mean becoming more able to give you suggestions that you want to take into your code base, and through that they are more secure. So I think it is getting better, but as I said, those standard practices, your security scans, your principle of least privilege, all that sort of stuff still needs to apply. Like absolutely, that should not go away.
Yeah, I've also found with the code review in particular, it does spot things that you may not have spotted as well. So I think that's good. But I would say that sometimes it can be overzealous. So I think it does need an experienced hand to know when to apply certain rules or not, when it's overkill. I think there can be a bit of a risk of just accepting all of the suggestions and then having a very fluffy code base with just loads of comments and things that may not be necessarily needed, I would say, and kind of decrease the readability and the comprehension of the code base. So yeah, I think being able to suss out the good from the bad of suggestions of the AI is also a skill, I think, in the future that developers will need to really hone, I would say. Yeah.
All
Yeah,
comes back to that, maintaining control, doesn't it? You still
Yeah.
know what to do, know what you want to deliver, make sure that's the right thing. Coming back to the software craftsmanship thing.
Becoming
Sorry.
a AI code whisperer. Yeah.
there was quite a good question that's been posted in the chat. What metrics should leaders focus on to prove AI is delivering real business value, not just productivity theater? I think this dovetails nicely with the ebook. I'm going to keep plugging that. Our ebook defined elite performance in terms of DORA metrics. So the DORA research report set out a few key metrics to monitor. Those were deployment frequency, lead time for change, the change failure rate, and the time to restore service after an outage. It's quite a high bar to hit. But sort of open question to both of you. What does an elite team actually look like to you? Can you put a number on it? Can you tell me the intangible thing that sets that team apart?
It's a very sort of it's a very simplistic question, right? Because you might see an elite team for one organization might be different from an elite team for another organization. I think the key, certainly from a platform engineering perspective, is that you're providing, this is a horrible answer, but you're providing value to the business, right? So when we come to CI/CD, what that might look like is that you can deploy when you want to deploy. Now, that doesn't necessarily mean when you look at DORA metrics and they say you must be deploying multiple times a day, and you must have, your lead time changes must be within a day and things like that. I think that is something we have absolutely seen for some of our larger clients who maybe have millions of users and they need to get features out quick and be confident in them and keep on moving forwards. So areas like e-commerce, for example, you might want to get your features out quickly to customers, right? But in the more regulated environments, so say for clinical trials or energy sector, things like that, you don't necessarily want to release all day, every day. You might have certain regulations that mean you're only able to release every few months or something like that. So I think an elite performance team is a team that is able to deliver the software when it's needed to be delivered. And in that second scenario where you've got kind of monthly release windows, which is perfectly normal. I remember when I was starting out and I was like, we have to deploy every time. We have to go every single CI/CD pipeline I looked at that wasn't delivering multiple times a day, I thought was just rubbish. But in reality, that's obviously not the case because businesses aren't able to release that often. But I guess in that scenario, you need to have software that is available to be released, like you said, Ed. So you can start to measure in slightly different ways. So how often do we actually deliver software that is of production standard, but not necessarily deployed to production?
That's where feature flags can kind of blur that line, though, can't they? Because the definition of release to the customer and release to production then split. Like in a traditional environment, when you release code to production, it's live and customers experience it. But feature flags let us split that into it's on the production server and the code path that has changed is actually being used by a customer. And I think that's probably a missed pattern in the DORA metrics, like that definition of delivering value to a customer. I don't know how they would measure it. It's probably an incredibly complex topic, but it feeds back into that your point about elite teams delivering what's needed by the business, and numbers actually taking a backseat to that potentially.
Difficult to sell though, right? To your exec level people, like how do you say you're working on the right thing? I guess ultimately you come back to the business metrics of increased revenue or increased retention or reduced support tickets, things like that. But yeah,
Yeah.
it's a difficult thing to kind of crystallize what value is to a business, because it changes for every single business.
And Fane, when you want to set up, what we would consider an elite team, one of our squads going in, say, greenfield development, what practices do you look to put into place to set these strong foundations, and why?
So yeah, I guess if I've got a quite senior team who's had some experience with trunk-based development, um, I would definitely recommend it. I'm working on a client at the moment where we've decided to go with trunk-based development. Most of our devs have used it before, have a couple client devs who kind of heard of the idea. And it's really smoothed out our like delivery, I would say. Um, Previously, I've been using Gitflow with some clients, and you always have the issue of getting to the end of the sprint with all of these enormous PRs that need to be reviewed by members of the team, and there's a big headache at the end of the sprint, and it's very anxious. And then finally, you've got it all done, and then you kind of can relax. But now it's just so easy because the developers who are pairing, they'll be doing their code review between them, and they'll be constantly merging into main. I'll be going in and doing spot check to see if we're kind of generally on the right track. And by the end of the sprint, because it's all been merged in, there's none of this kind of like merge hell. Everything kind of just flows through the board, and it's it's just quite nice and peaceful for me really as a tech lead, I think. Yeah, it can be quite painful going back the other way. And also, in Codurance, we always by default kind of do TDD and try to make sure our code is clean. And if you're doing all those practices, but you're not using trunk-based development, you're kind of missing a trick here. You've done all the work, but you've not got the reward at the end, I'd say. So doing all those important things, it just makes complete sense to do trunk-based development. I would say that there is a little bit of a learning curve in terms of some of the client devs were, I guess, using AI to kind of making a prototype of what they'd want for their story. But then you're kind of they were having to write tests against all of the features, and then eventually you've basically got this huge PR. So again, you need to kind of start from using TDD, small increments, to be able to make sure any code that you're writing is tested. That is the kind of absolute non-negotiable for trunk-based development. So one leads the other. Making your test, doing your feature, right? Get it reviewed. Small PR. Cognitively, you're just looking at one commit. And me as a tech lead, very easy for me to mark off. Rest of the team, very easy to mark off. It's just so smooth. So yeah, highly recommend if you can get your team into that kind of mindset of small increments, and also making sure that you're feature flagging off anything that doesn't need to be released immediately. Yeah.
I mean, I remember working in environments with Gitflow, like extreme Gitflow, probably. Lots of long-lived feature branches. I remember literally writing a bot to merge commits from main back into each of these branches. Utter hell.
It can be, but you've also got to recognize that for organizations who have maybe been doing Gitflow for years and years, trunk-based can sound quite scary, right? Because they're like, oh, what happens? Like we've got one branch of code. What happens if something goes wrong? And I think it's a lot easier to start out with trunk-based development and move to it. I think on a recent project we've started to move to it, but I think it's almost like I feel like it's almost maybe there's an echo chamber in Codurance, but it's almost accepted in the industry that is kind of the way to go. And what I like about it is that it forces these good practices, because you can't just kind of live on these little branches because if you go the opposite way and merge in huge long-lived branches while doing trunk-based development, you're just going to completely fall over.
Question from the chat that's quite relevant. How well does trunk-based scale? My last job had a big GraphQL server with many hands on it. I think we would have struggled without branch-based. I'll open that one up to both of you.
Yeah, so actually we experienced this last sprint actually where so we were using Trump-based development, but the guys are all kind of all working in the back end. And there was one change which kind of affected more files than we expected. And so yeah, you're gonna have those kind of like conflicts, I think, when you're working in areas that are quite similar. But I think there's a little bit of strategy in terms of um, the work streams, I think, in terms of delivery, making sure you've got well separated work streams, I think is really important. I think there's something around like team size here as well. After a certain size of team, you will start kind of treading on each other's toes. So don't think it's a silver bullet. I think you do need to kind of be a bit strategic in terms of where you're working. You'll still have conflicts if you are working on similar files, I guess. But yeah, it'd be good to know if there's kind of a bit more detail on why you guys have those issues. Yeah.
There is a common misconception that trunk-based development means you don't use branches ever. Um, it doesn't. You still use branches, at least most of the time that we've seen. You know, a very small project, you probably could just use main. But what it really means is short-lived branches. You know, they should be open for a couple of hours before you get your feature in. If it's not ready, you feature flag it and it doesn't get merged. Sorry, you feature flag it, it doesn't get activated. And that's that split between the code sitting on the server and actually being used by customers that we were talking about earlier.
It's a small change, isn't it?
Yeah.
You need to really, really reduce that cost of change and get that fast feedback in order for it to scale. Otherwise, yeah, it'll be very, very tricky.
And there's an issue hiding there as well that if you've made a load of changes on a branch, those aren't communicated to anyone else, like implicitly, unless someone goes in and explicitly looks at what you've been up to. It's very difficult for them to find out, and they may be changing the same stuff. They may be changing different stuff that affects it. Without that, like those sort of short branches being merged in frequently, it keeps everyone up to speed with what the code base is doing and how the code base is evolving. And that becomes, you know, even more critical when you start accelerating the speed of development with AI, because you can very easily have these enormous branches that, you know, they might have 10x the changes of a normal pull request. And I don't think you can merge that safely, can you?
Something we had to get on top of on a recent project, wasn't it, about really reducing those size of those PRs, because that can become a blocker in itself. There's a point in the chat actually that Chris has just put in around reading code now takes longer than writing code.
Reading code always took longer than writing code. That's not a new thing, though.
I'm just terrible at writing code then. But I think that kind of leads into, like, if you've got these huge PRs where there's shed loads and shed loads and shed loads of code, then that's inherently going to slow you down if you're going to have manual reviews. But one thing we managed on a recent project, I think that Fane's on now actually, is really lean into pair programming, because by having those two eyes on the code, there's less of a need for that PR review because you've had two people look at and work on the code together. You can, using that method, you can kind of reduce that need for these big PRs which code generators could build.
Does pair programming still work well if you've got an AI co-pilot operating on the side, though?
I've had good experience of it. I think I saw that James has joined from one of our previous clients at PitPat, and we pair programmed on that project very, very heavily, and we used AI tooling to do that. And I think especially when the need to keep your eyes on the code, given that AI is generating so much code, it's beneficial to have another pair of eyes on it as well. So I think while you can use, I mean, personally, I quite like to use the AI coding assistants as like an expert on the side who I can kind of consult with. But if you're using it in the agent way to create code, then I think absolutely having another pair of eyes on it is crucial, really. When we talk about using these tools, you're probably still solving problems together, right? And I always prefer to do that with someone else. Go on, Fane.
Yeah, no, I totally agree. I think it's, it's another bit of content, like, whether or not you're like pairing and taking a look at the docs or looking and trying to work out some Stack Overflow solution. It's always good to have another set of eyes with a different perspective to, validate it's actually legit or not, or if there's any kind of drawbacks that you've not seen. So, yeah, I think it's important.
People often think that pair programming is going to slow a department down. Thinking organizationally that we do see a fair bit of resistance to bringing it in because there's this impression that effectively halving the number of people working on independent features is going to halve the velocity. But we never really see that, do we?
Quite interesting, actually. I worked on a client so it was kind of like a commodities in pricing intelligence platform. The devs I was working with, they've not really worked using pair programming before. For a long time, they were just delivering individually, and I did notice there was some code quality issues that were slipping into the code base. So I did suggest the pair programming. There was a lot of resistance around, the velocity being dropped. There was a lot of pressure to deliver in this environment, and I kind of understood that that was, the case. But I tried to kind of let them, have one sprint of experimenting with it. And funnily enough, we did have, uh, you know, people pairing less stories in flight at the same time. But by the end of the sprint, the velocity was basically the same as it was for the previous one. So we didn't lose any more velocity than we had before. However, our code quality did improve over time. So yeah, it's interesting. Yeah.
Um, there's a question that's been sat around in the Q&A for ages, so I feel like we should probably get to that. And it's a business value one rather than individual sort of pair programming questions. Hannah asked, how long does it take typically to see measurable impact once you introduce AI into delivery? And I think that's a really topical question because quite often we see a measurable impact on the velocity, like the coding volume immediately. I think it's safe to say. Would you agree, Fane?
Sorry, I was reading the chat.
Sorry, you
say
see a
that again?
measurable impact on coding volume immediately, but that's kind of correct, isn't it? The development velocity immediately spikes.
Oh yeah, totally. I mean, AI code assistants can generate so much code, but as we've kind of stated before, is the code kind of going to be valuable, and is it gonna help you in the long run in terms of your architecture? But I guess there's the product aspect here too. So having a clear kind of product vision and requirement is absolutely key. I think pre-AI as well, to making sure that you're actually building the right thing. Um, yeah.
So that sugar rush is really interesting because you will see that increase in coding volume, but there is a significant delay in business impact following on from that if you don't have the right foundations in place. It could easily be 6 months, 8 months, or even never if you don't have these strong foundations in place. Even if you've got them in place, it can be a couple of months before you've ironed out those like the kinks in the framework.
I mean, the question was about impact, right? You're going to see an impact straight away, whether it's a positive one or a negative. You're going to see an impact straight away.
I was
So
trying to think positively, Sam. I think you're right. Like you'll see a sort of 20-30% increase in pull requests, lines of code generated. This stuff is great, but it's kind of a trap. People mistake that for success. But if the deployment frequency is, say, once a month or once a quarter, you've just built a bigger waiting room for your code. You've increased the pressure on everything up the pipeline because it can't go anywhere.
Yeah. Yeah,
Go on.
sorry. Yeah, because I guess you just kind of made me think about, I've read quite a lot about the bottleneck really comes into review because you're speeding up all of your code generation, but then that kind of puts a lot of pressure on all of the reviewers. So one thing that I found, I guess I've touched on is with the chunk-based development, because it kind of forces you to be making these smaller commits. It kind of limits the blast radius of this explosive, code generation by AI, giving you a bit more time to be able to actually look through, get that early feedback, and make sure that it just doesn't grow arms and legs that it doesn't need. Yeah, so I found that quite useful.
Yeah. And, once you properly sort of automate your governance and trust the test suites, things like the manual review load go down. The need to like really in-depth check PRs, this sort of stuff. If you've got all these elite performance practices like pairing, short-lived branches, and like proper DevSecOps, CI/CD test suites, you start to see your deployment frequency come up to the level that AI coding can kind of deliver in velocity. If you can start shipping multiple times a day instead of once a sprint, this sort of stuff, you can start delivering value to your customers much faster. So I think there was another question in chat about how do you measure the metrics. Well, don't measure AI adoption by the lines of code written, because you incentivize that behavior where it's all about writing that code and just getting it merged and not delivering value to your customer. Start thinking about things like cycle time as being more important. That time from first commit to production. If AI helps you code in 1 hour instead of 4, that's brilliant. But deployment takes 3 months. That's negligible. There's like no gain there at all, really. If you fixed your underlying systems to deploy in 1 hour, bang, 90% faster. AI is the engine, but your transmission needs fixing as well, and you need both to work in tandem.
I'd recommend to do a value stream map if you haven't done a value stream map. I love them because that basically shows you the end-to-end process of your delivery of value to customers. And by interrogating that, you can figure out where you actually need to optimize. Because like you said, Ed, it could be AI coding is just one part of the process, right? There's a whole other number of processes and maybe hundreds of processes in some organizations that actually get to the point of shipping code out, and maybe the focus needs to be somewhere else. So do a value stream map out how you get from requirements to deployment to production, and then basically time everything and look at your batch size and things like that, and focus on the stuff that'll help you to identify the bottlenecks and where you need to focus.
Well, that was where the ebook originally came from, because the client asked us, hey, we're having a problem with value delivery after introducing these AI tools. What do you recommend we do? And actually, we had a bit of think and thought, we have all these practices internally that we haven't really written down and talked about externally. And so the ebook came out of this desire to talk to people about how to accelerate that. We've got time for a couple more questions, I think, before we call this webinar. I'm just scanning the chat. If you've got any more, do get them in before we've got 6 minutes left. There was a question about, if you pair program, do you still do a PR review? I think we did cover that a little bit earlier, and I've also answered it in the chat. You usually do it with the other person in the pair. There was a wider question here. Do you let a third developer have a look at that PR, or is that just a waste of time? So interested to hear your thoughts on that.
Yeah, so I think I put a message back, and I think if you're pairing on a feature and it's like quite low risk and you feel quite comfortable with it, then yeah, I think the code review is like fine between you. I think it just takes a little bit of self-reflection on if you're both feeling a little bit hesitant about the code, if there's something that you're not sure about between you. I think it's as simple as just having a chat with someone in the team who might have more experience, getting that extra pair of eyes until you feel comfortable. I think it's quite important to develop that intuition of where you feel not comfortable with any code that you've written, and I think that's okay. But obviously that takes a lot of trust in the team. You need to be comfortable being kind of vulnerable with your code. I mean, obviously that counts for pair programming too. But yeah, I think it's important to kind of keep that communication up. I also think that's part of, I guess, one point for like what is an elite team. If my devs feel like they have autonomy and like they're able to go and run with ideas, and propose solutions, I feel like I'm in an elite team. They feel like they're empowered to be able to kind of make these choices, but they've got the safety net of everything we've put together. Then I feel like I'm in an elite team because they can move forward with things rather than having myself or anyone else like dictate how to do things. They're all moving together as one. So I think there's that kind of magic of having that kind of team that enables that fast delivery, I would say. Yeah.
There's a fairly related question in the chat. Have we got specific examples of practices that help a pair to work with these sort of AI tooling on the side? We find pairing remotely plus Copilot becomes a struggle to keep both halves of the pair engaged and connected.
Pilot Navigator would work, would it? Because you need to be reviewing those AI outputs straight away anyway. So someone's doing the prompting and someone's doing okay, let's see what's happened here and go step by step. I guess what you don't want to do is fall into the trap of one person's just writing a load of prompts and then accepting changes and then carrying on doing that, and the other person's basically just watching them use Copilot or Cursor or Claude. I think the way to be engaged is to kind of linking back to what you said, Fane, about having rigorous communication, talking about stuff, have a look at the code, what's it doing, what we're going to do next. Maybe one falls into an architect role. Okay, we want to take this approach and go here. The other person's coding, doing the live coding. I think you have to insist on working together.
Yeah, I think taking maybe a bit more time between the stages of, exploring and planning, having a discussion about the kind of exploration ideas that the AI is kind of generated, what's fishy, what's not fishy, have we sort of we missed something, I guess. Then while it's executing, kind of you'd hope that the other devs would be able to see the output that it's creating, being able to kind of watch if it's getting stuck in a death loop or doing something weird. Yeah, I think taking the time to stop at each step and see what it's done. It sounds really simple, but yeah, I think that's a good way of working with AI coding tools as a pair, I would say. Yeah, more discussion.
Another interesting one. We've got time for a couple more. In an elite team, when you have heavy AI use, do you recommend having dedicated QA? We've actually just guided an organization through this transformation. And it's a tricky question because obviously we're talking about people here. And in any transformation, you do have to remember that we're talking about people's jobs and careers here as well. No is the answer most of the time, because quality assurance is, I think in our experience, mostly a role that tends to act as a blocker. And that's how that role is seen. If you tell someone there's QA, they will automatically do things like throw the testing of that software over the wall to that person and abdicate responsibility. I think our preferred approach is quality engineering, where you have someone in the squad kind of replacing that QA role, who is a proponent of quality and how to test better, how to use tools to generate better test suites, this sort of stuff. And they're working on that testing infra. And they're your person who you can turn to and say, hey, I need to test this. I need to do X, Y, Z. How do I do it? That way, they're more focused on your elite performance underpinnings, your CI/CD, your continuous delivery, continuous deployment, and getting the roadblocks out the way. And that's how you can move faster in an elite team, rather than having dedicated QA. Would you guys agree?
You need to apologize to all the QAs who are on this call, I think, to say they slow people down. I think, I think I 100% agree with quality engineering, and that's what we try and embed. And I think there is a role for people to embed those quality engineering practices, and it's something that we see across organizations as well. I think the only caveat I'd have is that I think there's the whole, it depends on the organization. If there is a heavily regulated organization where there is a demand that there is a separate QA role, then absolutely they should exist. But I think what we try and do is a lot of our teams that we put into clients have their teams of engineers. We don't, as far as I know, employ any QA engineers or specific testers, because we try and embed those quality practices throughout, and that's an expectation we put on our people. To kind of backtrack up a little bit, Ed.
It's something we spend a lot of time coaching clients on, is that embedding quality throughout the life cycle, rather than having gates in place, specific people who need to test something, specific steps that things need to go through. Would much rather embed quality at every stage, so you don't need to have those blockers. Great. Thank you everyone for joining. We are out of time on this. Sam, Fane, thank you very much for your insights. And thank you everyone for your questions in the chat. Do reach out to Codurance if you want some help with that. We've got a little bit of experience in some of the topics we've discussed today, so we'd be more than happy to talk about how we can make it work for you. And hope you all have a great rest of your day. Thanks for joining.
Thanks for joining, everyone. Have a good day.
Bye.